Let's now have a look at multiplying fractions. Number 1, we have 2 over 3 times 4 over 5. Now when we multiply fractions, we just simply multiply the two top numbers together, so the two numerators, and then the two bottom numbers together, the two denominators. So here we go, 2 times 4 is 8, 3 times 5 is 15. Number 2. Now, before we multiply the two top numbers together and the two bottom numbers together, what's very important to check and see if we can make the top numbers and the bottom numbers smaller. So can we cancel? Now, if you look at this carefully, we can't cancel or simplify this fraction on its own because there's no common number that divides in the top and bottom, and same here. But what we can do, we can cross-cancel this way and cross-cancel that way. Why? Because there is a common number that divides into 6 and 8, and that is 2. And there's also a common number that divides into 25 and 15, and that is 5. So let's cross-cancel between the 6 and the 8. I divide 2 into 6 3 times, and then 2 into 8 4 times. I now cross cancel between the 25 and 15. I go 5 into 25 goes 5 times. 5 into 15 goes 3 times. So we're left with now 3 over 5 times 3 over 4. Now I can multiply the two numerators together and get 3 times 3 is 9. The two denominators together, 5 times 4 is 20. So I'll say it again, where possible, make the top and bottom numbers smaller by cross-cancelling. Now every time you cross-cancel, you must always do it in pairs. Okay, the next example, we have 12 over 18 times 5 over 7. Now, I can't cross-cancel between the 12 and 7 in this example and the 18 and 5 because there is no common number that divides into 12 and 7 and no common number into 18 and 5. But if you have a look at the 12 over 18, you'll notice I can simplify this fraction. Why? Because 6 goes into 12 2 times and 6 goes into 18 3 times. So where possible, always simplify the fraction itself. So we now have 2 over 3 times 5 over 7. Now I just multiply the two top numbers together. I get 2 times 5 is 10. Multiply the two bottoms together. I get 3 times 7 is 21. Okay, so let's have a look at number 4. We have 16 over 40 times 15 over 24. Now, can I make the top numbers and the bottom numbers smaller? Yes, I can. I can make them smaller by cross-cancelling this way. And I can also make this number 16 over 40 smaller because I can simplify. But what we can do, we either cross-cancel or simplify. It doesn't matter which we do, but what we'll do, firstly, we'll cross-cancel the 16 and the 24 and the 40 and the 15. Now, 4 goes into 16 4 times. 4 goes into 24 6 times. Now, you notice here, I didn't choose 8. 8 would have been a better number, but sometimes you can't find the highest common factor. And if you can't, then all you simply do is cancel again. So what I can do, I can go 2 into 4 2 times, then 2 into 6 3 times. As I said earlier, it would have been easy to choose 8, but if you don't find the highest common factor, it doesn't matter because you can always cancel twice. Now I can cross cancel this way. 5 into 40 goes 8 times. 5 into 15, 3 times. So what we're now left with, we're left with 2 over 8 times 3 over 3. So you'll notice now we can't cross cancel this way or this way, but what we can do, we can simplify the 2 over 8 and the 3 over 3, because 2 goes in itself once into 8 4 times, and 3 in itself once, and in the bottom as well once, and we get 1 over 4 times 1 over 1. We multiply the two numerators, of course you get 1 times 1 is 1, 4 times 1 is 4, and that is our final result, 1 over 4. Now let's redo this problem again. And what I'm going to do this time, instead of cross cancelling first, I'm going to simplify this first fraction here. So I have 16 over 40, so I can divide 8 into 16 2 times, 8 into 40 5 times. Now you'll notice what we have 2 over 5 times 15 over 24. Now I can cross cancel. I can go 5 in itself once into 15 3 times, 2 into itself once into 24 12 times. Now I'm left with now 1 over 1 times 3 over 12. Now as you can see, I can simplify this fraction here, 3 over 12, by dividing 3 into itself once into 12 4 times. So I'm now left with 1 over 1 times 1 over 4. Multiply the two numerators together, I get 1 times 1 is 1. The two denominators together, I get 1 times 4 is 4. And of course, they are the same. So it doesn't matter which you do first in this case, whether you cross cancel or simplify the fraction, you'll get to the same result eventually. Okay, let's do number 5. We have 5 1/3 times 2 1/4. Now you notice this example is different from the others because here we have mixed numbers. 5 1/3, 2 1/4. So in cases where you have mixed numbers and we're multiplying, always change these mixed numbers into improper fractions where the numerator will be larger than the denominator. So we go 3 times 5 is 15 plus 1 is 16 over 3. Times, we go 4 times 2 is 8 plus 1 is 9 over 4. Now, as you can see, we can cross cancel here. The 3 and the 9. 3 into itself once, 3 into 9 3 times. 4 into itself once, into 16 4 times. Now, we're now left with 4 over 1 times 3 over 1. Now we multiply the two top numbers together. We get 4 times 3 is 12. The two bottom numbers together, 1 times 1 is 1. Now we don't leave the fraction as 12 over 1 because we know 12 over 1 is equal to 12. Okay, so let's now have a look at the rules for multiplying fractions. Now the rules are, first, where necessary, reduce the numerators and denominators into smaller numbers by cancelling. Now you must always do that first if it's possible. Then multiply the numerators and then multiply the denominators. And that's exactly what we did in those examples. Now what is cancelling and why is it important? Now, cancelling involves finding the largest number that will divide into a top number and a bottom. Now, this number is called the highest common factor. And then performing this operation with each cancelling action must be done in pairs. Now, I emphasize that in the examples we did. Every time you cancel, you must do it in pairs. This means cancelling can occur vertically between the numerator and denominator of its own fraction. In other words, simplify the fraction or cancel it. Or diagonally crossways between the numerator of one fraction and the denominator of the other. And that's what we did when we cross-cancelled. Now this procedure is important because it reduces the numerators and denominators into smaller numbers, which makes the rest of our calculations easier. So the cancelling process is very, very important when we multiply fractions.